Hello, the objective of this video is to learn how to interpret linear graphs. Now, when you're asked to interpret a linear graph, you have to be able to use full sentences to describe different parts of the graph and to relate the data to the real world. This is a real world skill. You are going to come across the need to read graphs in many different jobs, or even in the news to be able to read and interpret the graphs there. If you don't know how to read them properly, you're not going to look that intelligent and you may end up getting bad information. So you want to make sure you can read graphs correctly and be able to transmit that data, be able to tell that data to other people. So it's important you be able to interpret graphs correctly. One of the tires on my minivan has developed a slow leak. True story a couple weeks ago, but that's besides the point. The graph at the right displays my tire pressure change as it slowly leaked air. Now, one of the questions you could be asked about this graph is, what was the original tire pressure? Well, looking at the graph itself, the original pressure would be what it was at the beginning. At the beginning, the time is 0. Well, what was the tire pressure when the time was 0? Well, you go up, and you look, and that's the point where the pressure is at time 0, and that pressure is 40. So the original tire pressure is 40 psi, or pounds per square inch. You do want to write a sentence like this, where you actually are restating the original question. The original tire pressure, that's all from the original question, is 40 psi. Remember that CSRQ, complete sentences that restate the question. All right. Note, this is also known as the y-intercept. When the x value is 0, time being 0 in this case, your y-intercept is going to be 40. Now, how many days did it take to become completely flat? In order for a tire to be entirely flat, it has to have a 0 pressure. Well, 0 pressure would be right there. What would the time be when it hit 0? Well, here's the line, and it hit it right here at 8 days. So it took 8 days for the tire to become completely flat. To become completely flat. To become completely flat. Restating the question. No, this is also known as the x-intercept. This point right here, the y value was 0, and that gave you the x-intercept of 8 days. Okay, what is the slope and what does it represent? Well, in order to do the slope, you need to have 2 points. It could be any 2 points in this line. Are they going to draw two nice little circles like that all the time? No. I chose these points. I could choose this point, I could choose this point, I could choose this point. I'm looking for points where the line crosses nice intersecting grid lines on the graph itself. Well, I chose those 2 points. So starting from that point, I want to do the rise, which in this case is going to be negative because I have to go down. So I got negative 25 rise. Why is it 25? Because I'm counting by 5s here. See, the interval here is 5s, not 1s. So it's 5, 10, 15, 20, 25 down. And the rise over the run is the slope. So the run here is, well, they're counting by 1s. 1, 2, 3, 4, 5. So I have a run of 5. Negative 25 over 5 is your slope. Simplify that. It can be simplified. You get an answer of negative 5 for the slope. Now, they asked us what it represented. This is only half the question. The other part is, what does it represent? Well, to do that, we have to look at slope. Slope is the change in y over the change in x, and the y deals with tire pressure, and the x deals with time. So our sentence that responds to what it represents has to include something with the y-axis description and something with the x-axis description. Y being on top, the time being on the bottom. So we're talking about tire pressure per time. Well, the words tire pressure per time doesn't make sense. What about tire pressure per day? That makes a little more sense than per time, right? So we're talking about tire pressure per day. Could we also say pounds per square inch per day? Yes. PSI per day, we could do that too. But I decided to stick with tire pressure per day, but I also have to remember that this is a negative slope. So that tire pressure is not getting higher, it's getting lower. So what I'm saying here is the slope represents the tire pressure lost each day. That tire pressure change was a loss. If it had been a gain, I could say the tire pressure increase each day. At some point the tire would explode if I kept increasing the pressure, but we'll move on from there. Note, this is also known as the rate of change. We should know that slope and rate of change are the same thing. All right, Mr. Kirk climbed a mountain. This graph represents his trip from his first campsite on the mountain to his last day, to his day at the beach. I'm sorry, first campsite on the mountain to his day at the beach. And he does go up to the summit at one point there. What is the altitude of his first campsite? Well, let's see here. His first campsite. Well, that's the starting point. That's at time 0. Time 0 is here, which means it's at 500 feet. So the campsite must be at 500 feet. The campsite is at an altitude of 500 feet. All right. The next question is, according to the graph, what did Mr. Kirk do his first day? Well, his first day would be represented by this part right here, from 0 to 1. That's his first day. What did he do? Well, he started off at the camp, and he didn't quite reach the top yet, did he? No, but he did make some progress. Is he going up or down? Well, his height started at 500, and somewhere here at 1750, so he is going up. The answer is Mr. Kirk climbed part of the way up the mountain. Didn't make it all the way to the top, but he climbed part of the way. If we wanted to be a little more exact with that, we could note that it's about halfway between 1,500 and 2,000, and we could say it was 1,750 feet the first day. He made it 1,750 feet up the mountain that day. How high is the summit of the mountain? Well, the summit is that point at the top here. How do I know that? Because he didn't go any higher. He climbed to the summit, and he didn't go any higher. So the highest point he reached was that 3,000 feet. So the answer is going to be 3,000 feet, because if you go along over here, you'll see that that line is at 3,000 feet. So the mountain is 3,000 feet high. How long did it take for him to get to the summit? Well, he started off at 0, of course, and then he went to the summit. This is where he reached the summit. Let's read the time at that point. You go down here for the time, because the time is the x-axis here, and you'll see that the time was 2 days. So it took Mr. Kirk 2 days to reach the summit of the mountain. What does the flat part at the top of the graph represent? True, it is the summit, but it's more than that, because it's not one point, it's a length of time there too. It represents the time he spent up there at the mountain top. He didn't go down any, he didn't go up any, he stayed right there at the summit. So that line there is when Mr. Kirk stayed at the summit. How long did he stay there? He stayed there for a day. So that flat line gives you more information than just it's the top of the mountain. It's not only the top of the mountain, it's Mr. Kirk stayed there for a day. You got to make sure, because they're talking about some length of time here. You got to include that in your answer. You can't just say it's the top, because it's not one point. It's a length of time here as well. Okay, how long did it take Mr. Kirk to get to the beach from the summit? Well, the summit was the top of the mountain, right up here. And the beach, well, where's the beach? The beach is at sea level. And sea level, in terms of altitude, is 0. So when did he get back down to 0? He got back down to 0 over here. So to get from the summit to the beach, he started on day 3, ended on day 5. That's a 2-day trip down the mountain. So it took 2 days to travel down the mountain to the beach. Was there any difference between Mr. Kirk's trip up the mountain and his trip down? Well, aside from the fact that he went up instead of down, there is another difference. On the trip up, he started at base camp. Base camp was not at sea level. At the end of the trip, he went all the way down to sea level from the summit, which means he covered an extra 500 feet down. It took him 2 days to get to the summit, it took him 2 days to get down, but he traveled an extra 500 feet on the way down. So it looks to me like he moved a little bit faster down that mountain. Same time, more distance, more altitude here, means he climbed down faster. Could you have also said he climbed down further than he climbed up? Yes, that's another good observation. But if you do speed, you'll get those like extra bonus points for having been smart enough to know you're talking about speed here. Okay. My son got a balloon at Publix. When you go to Publix, you got a little kid, they can get a free balloon. I got a balloon there. When we got home, and he accidentally let go of the string and it flew away. The graph shows the height of the balloon as it flies away. What is the speed of the balloon? Speed. Speed is, well, first thing I think about when I think about speed is miles per hour. Miles per hour is a distance per time. Distance, time. Well, if we're talking about distance per time, we're talking about the slope of this line. Change in y over change in x. So we need 2 points to find the slope. And I could choose any 2 points. I'm looking for ones. No, this one's not very good because it's not a very good point to read, but this point's good because it crosses at intersecting points. This one also crosses at intersecting points. This crosses at intersecting points. I could choose any of those. I chose these two. To get from this point to this point, moving from left to right, I would go up first. I would go up 150, 100, 150. So I go up 150. Remember, the intervals here are 50, not 1. So you got to be careful when you're counting for that rise. You got to count by the intervals that you're working with here. The run, it went from 2 to 3 to 4. So we're talking about 2 minutes. So the slope would be the rise over the run, 150 over the 2. 150 over 2 simplifies to 75. So the balloon is traveling at a speed of 75 feet per minute. I don't want to say 75 height per time, do I? Could I have written out the word PER instead of the slash? I could have done that. Could I have abbreviated feet to FT? Yeah, I could have done that. Could I have written out the full word minute? Probably should have. But there's the basic fact here is I've got the speed, and we're talking about speed because it's what is it asked? What is the speed of the balloon? The speed of the balloon is 75 feet per minute. Okay, my son let go of the balloon. He's crying, he's crying. He cries for 5 minutes. After he's cried for 5 minutes, approximately how far up is the balloon? Well, here's 5 minutes. To figure out how far the balloon is, I have to go from the 5-minute mark. I go up to try and find out where the line is at that point. That's where the graph is at that point. Now, going over to the height here, it's not exactly the 350. It looks like it's halfway between the 350 and 400. So I would say it's about 375 feet. They did say to approximate, so I'm going to do approximate. It's about 375 feet. Notice how I put the word about in there. When you're giving an approximation, you can't say the balloon is at 375 feet. You need to say it's about 375 feet because your answer is not exact. It's an approximation. How can we calculate the exact height to be absolutely certain it was 375 of that? Well, we would do that by creating an equation for the line. Well, to create an equation for the line, well, that would be our next question. What is the equation for the line? To do that, you need to remember that we've worked with this y equals mx plus b. That's the form of an equation. So the height, the y-axis would be the height, the x-axis would be time. So the height is equal to m, the slope, which we already calculated. The slope is 75, and plus b. Well, b is the y-intercept. It's crossing the y-axis at 0. Since it's close to 0, that means my b is 0, which means it can be ignored. It's just going to be the y equals mx, which the slope we said was 75. So our equation is y equals 75x. And we could use that to find the exact time. And if we do 5 times 75, you are actually going to get 375. This graph represents the weight of a bucket as it's slowly filled with sand. How long did it take to fill the bucket? Well, starting at 0 time, we're looking for when the bucket is full. Well, when will the bucket be full? Well, the weight, once you fill it, is the weight going to change at all? Because you keep pouring stuff in, it's just going to go pouring all over the place. It's not going to go into the bucket. So where does the weight stay the same? Up there. At that point, the weight does not change. Even if you're pouring more sand and more sand in, the bucket's full. It's not going in there. So how long did it take to get filled? Well, it would be, that point would be at, all the way down here, follow down here, is at 7 minutes. So it took 7 minutes to fill that bucket. How much does the empty bucket weigh? Now you might think this is a trick question, but it's not. The bucket does have a weight. Every bucket has some weight to it. The question is, how much does it weigh? Well, when the bucket was empty, you hadn't started filling it yet. So what was the time when it was empty? 0. What's the value there? 2. So the bucket is empty at 2 pounds. The bucket weighs 2 pounds when it's completely empty. No, this is also known as the y-intercept. So if you're asked to describe what the y-intercept represents, it represents the weight of the empty bucket. Now, how fast is the bucket being filled? Again, we're talking speed. Speed is going, when you've got a weight times time, anything times time here, you're talking about speed, which is slope. So I need to choose 2 points. This one's already chosen, I'll choose this one as well. To get from this point to that point, I would have to go up 3 and over 3, which gives me a slope of 3 over 3, which is a slope of 1. So the bucket is being filled at the rate of 1 pound per minute. I don't want to say weight per time, so I use the units. Pound per minute. How many pounds of sand does the bucket hold? Well, remember, it weighs 2 pounds empty. How much does it weigh when it's full? 9 pounds. So if it weighs 9 pounds full and 2 pounds empty, 9 minus 2, we get 7 pounds of sand. That's how much the bucket holds. If you empty the bucket twice as fast as it was filled, how long would it take to empty the bucket? Well, it took 7 minutes to fill the bucket. And if we're filling it, or dumping it out twice as fast as we filled it, that means it's going to take half the time. So what's half of 7 minutes? 3.5 minutes. So if you're asked this first, you'd have to figure out how long it took to fill the bucket, the 7 minutes, and then cut it in half to find out how long it takes to empty it if it's twice as fast being dumped. Speed would happen to be 2 pounds per minute, by the way, on that. Old McDonald had a farm, and on his farm he had goats and ducks. Altogether, his goats and ducks have 240 legs. This can be represented by the function 2d plus 4g equals 240. What does the highlighted point on the graph represent? There's the highlighted point. What does it represent? Well, every point is composed of an x and a y value. So when you're asked what it represents, you need to write out what the x and the y value mean at that point. At this point, the x value is 30, and it's the number of ducks. At this point, the y value is 40, and that's the number of goats. So the sentence would read, the highlighted point represents Old McDonald having 40 goats and 30 ducks with a total of 240 legs. That's what that point represents. That a total of 240 legs, that comes from the equation. Did I have to add that? No, but it's a nice fact to add to my answer. What does the y-intercept represent? Now remember, the y-intercept is where it crosses the y-axis, so it would be up there. Now the y-intercept is not just one number. Remember, it is a coordinate, and anytime you're describing a coordinate, you need to have two things being described. Not just the y value, but the x value as well. The y value is 60. So that's where you have 60 goats. But it's also where you have 0 ducks. So the y-intercept represents when Old MacDonald had 60 goats and no ducks whatsoever. What does the x-intercept represent? Well, the x-intercept is all the way down here. And again, it is a coordinate. It is a point. So you need to describe both the x and the y value at that point. The x value is 120. The y value is 0. So the intercept represents when Old MacDonald had 120 ducks and 0 goats. See you in class.